I'm excited to tell you about a story that really spans decades of computer history and goes through the heart of the personal computer revolution and is one of the first free software projects. And it's the story of TinyBasic. But before we get into TinyBasic, we got to kind of lay the groundwork. So we got to start with BASIC. Why do we care about TinyBasic unless we know why BASIC matters, right? So BASIC was started in 1964 by two math professors at Dartmouth College, John Kemeny and Thomas Kurtz. They wanted to explicitly build a programming language that was more accessible than the programming languages that had come before. In 1964, we're still talking about big iron mainframe computers that take up a whole room. And the types of programming languages that were available were things like COBOL or Fortran or Lisp or ALGOL. These were programming languages that were great if you were in the world of mathematics or engineering or science, and they weren't necessarily great if you were somebody who was more of, let's say, the more average mindset trying to use a computer. So they wanted to have an interface to computation that was accessible to other students at Dartmouth who weren't in those fields. And that was the reason for designing BASIC. And BASIC stood for explicitly beginners all-purpose symbolic instruction code. So they were explicitly building something that was friendly to beginners. So this is one of the first points, I think, in the democratization of computing. And there was more to it than just BASIC. They also were building out what was called the Dartmouth time-sharing system, which was one of the first time-sharing systems. It allowed more than one person to use one of these big mainframe computers at the same time, and it would split its time between all of the users, so it felt to all of them like they were all using the computer interactively, even though it actually was just constantly switching which users' commands it was processing at any given time. And just to give you some context, there weren't monitors, there weren't keyboards. They were using electric teletypes, like the one you see on the right here. So they had all these teletypes connected to the GE225 mainframe computer, and the teletypes were like electric typewriters. There was actually on paper that they were getting output back, and they were, typing on the typewriter, and that was being sent electronically back to the machine. So a very, very different environment than we're used to today, but an environment nonetheless that allowed individual users, in fact, hundreds of them across campus, and then actually they connected people across the entire region where Dartmouth is based in New Hampshire to this centralized machine. And so folks were actually able to have interactive sessions in a way that a lot of computers didn't have before that, where you'd have to put something onto punch cards and it would go through a hopper, and later in the day you'd get your results back. No, we could have many users using the computer at the same time and having immediate feedback back and forth. So that was very innovative, and BASIC became popular not just at Dartmouth, but it spread to other mainframes. Eventually it spread to mini computers, and then the personal computer revolution kicks off in the mid-1970s. Now, there had been things that were sort of kind of like personal computers before 1975, but the first computer that really had a big success, was mass-produced, and was really seen as the first mainstream, sort of mainstream, hobbyist, let's say, personal computer, was the Altair 8800, and it came out at the beginning of 1975. Now, the Altair 8800 is exactly what it looks like here. It was a big metal box with a bunch of switches and blinking lights on the front. That's not much of a user interface. To be successful, it would need to have a user interface that folks who were not completely technically minded would actually want to use. I'm talking about like your hobbyist who wants to get into computers but isn't necessarily somebody who's going to learn the spec sheet of a microprocessor. Or I'm talking about the small business owner who wants to do some calculations for their business, use some basic software, but doesn't actually, and personal computer software at this time wasn't really a thing yet, but doesn't want to get to the nitty-gritty electric details. So what would be a great user interface? Well, the user interface that had been storming the rest of the computing world, BASIC. And so the first folks who developed a BASIC for the Altair were obviously going to have something of an interesting business. And so Bill Gates and Paul Allen had already been working together by this time for years. They had met each other when they were in grade school, and in high school they had done several entrepreneurial ventures together. And they actually had already been programming for for years by this point together. And they had actually even a company called Trafodata back in Washington. At the point that the Altair comes out, Bill Gates is going to Harvard, and Paul Allen has just dropped out of school in Washington and is working at Honeywell, also in Massachusetts. So they're close to each other physically in Massachusetts. And they see a magazine that comes out that has the Altair on the cover, and they know this is our moment. This is what we've been waiting for, this moment to do something really big in computing. And through their Trafodata venture, they had already had some experience programming for what were then known as microcomputers. So they decide we can be the folks who build the BASIC for the Altair 8800. And they call up MITS, which is based in New Mexico, the company that's building the Altair 8800. And they say, we've got a BASIC. We can build a BASIC for you. The thing is, they haven't really built the BASIC yet. In fact, of course, the computer hasn't come out yet, so they don't even have access to the computer. So they arrange that in a few months they're going to go and meet with the MITS folks in New Mexico and show them their BASIC. But before they do that, they have to actually build it, and they don't have access to the machine. They did something that's kind of innovative. They built an emulator for the machine on one of the big iron machines at Harvard. So they had an emulator for the Intel 8080 microprocessor that was in the Altair 8800, and then they could program their BASIC interpreter for that emulator. The problem was, how do you know if it really works on the real hardware until you actually test it on the real hardware? And when they finally completed it, and then Paul Allen got on the plane, because Bill Gates looked too young and Paul Allen was a few years older than him, he got on the plane, and then he realized on the plane, I didn't write the bootloader, the part that kicks off the BASIC, starts the machine up and says, hey, we're going in BASIC mode now. He wrote it on the plane. And then when he got to the demonstration, he eventually got it working, and BASIC actually worked. And so Bill Gates eventually dropped out of Harvard. They formed a Microsoft partnership in New Mexico, moved to be near to MITS, and they started the company by manufacturing Altair BASIC, by making Altair BASIC for the Altair 8800. That was the start of Microsoft. If you're interested in this early history of Microsoft, this is just an aside, but I think these are awesome resources. I've read all of these books myself. I've checked out this movie many times, Pirates of Silicon Valley, one of my favorite movies. So 2 of these are memoirs by the founders of Microsoft. Hard Drive is just kind of an overview of the early days of Microsoft, and Pirates of Silicon Valley is an awesome movie about the early days of Microsoft and Apple. I recommend them if you're interested in hearing the details of the story and a lot more around it. Anyway, let's get back to our story, though, about Tiny BASIC. So, BASIC is now on the Altair, and a lot of hobbyists are starting to buy the Altair, and you know what? Other personal computing companies are starting to come up as well in the 1975-1976 timeframe. In fact, this is the timeframe when Apple gets started. The Apple I comes out in 1976. So even companies that we're still familiar with today are getting their start at this time. A lot of these folks who are interested in these hobbyist computers are coming from kind of a scientific or an academic background. And they start meeting together in clubs, the most famous of which is the Homebrew Computer Club, which is in the Bay Area in California. And they're famous members of that early club. Actually, Steve Wozniak and Steve Jobs attended some of those early meetings. And they are all coming from the same kind of electronics, science, academic background where they're used to software being something that is actually freely distributed or that comes with hardware. They're not used to paying for software. They see hardware as the thing you pay for. That was kind of the ethos in the early computing days prior to the personal computing revolution. So on the other side of the coin, actually what Bill Gates and Paul Allen were doing with Microsoft was very innovative in a business model sense too. They were one of the first companies to be a pure software company, especially for personal computers. In fact, they were there at the beginning of the revolution. They're arguably the first successful personal computer software company. But that's not the world that a lot of these hobbyists are coming from. And so they say to each other, and there's kind of a call for this from a guy named Bob Albrecht, who's one of the founders of the Homebrew Computer Club, why don't we have our own BASIC, a BASIC that we freely distribute? And he gets a friend of his, who's also in the Homebrew Computer Club, Dennis Allison, to create an initial specification and version of what they called Tiny BASIC. This was a version of BASIC that they did not charge any money for. And what's really interesting about it, beyond just that Allison makes the initial version of it, is that he also makes a specification that he then encourages other people to use to improve on it or port it to other platforms. In fact, quoting him from his original design document that he published in the magazine of an organization called the People's Computer Company, which Albrecht was also involved in, he wrote, "We'd like this to be a participatory design project." He wants the community to get involved. He wants other people who are reading the specification, reading his article, to go and contribute back. And in fact, they end up starting up a journal that eventually became a well-known programmers magazine called Dr. Dobbs Journal, where they publish different versions of TinyBasic. And we'll come back to that in a moment. But I would just want to mention, like, how could other people go and take what he did and re-implement it, especially hobbyists, right? We're talking about hobbyists. Well, keep in mind the computers of the time, the personal computers of 1975, 1976, have something like 2 kilobytes or 4 kilobytes of RAM, okay? So the language, when it's called TinyBasic, it has to be truly tiny. This is part of the specification. This is what we call the grammar, and it's how you specify the legal syntax of a programming language. And you can see in this grammar that there are only a few. The bold words are the keywords in the language, okay? And 4 of these are kind of meta control. Clear, list, run, end are kind of meta control keywords. The other ones are like the real language: print, if, go to, input, let, go sub, return. There's only 6 of them. If you checked out my prior video on the smallest possible programming language, this may look familiar to you because these are very similar to the keywords from the BF language that we talk about in that video. So go check out that video if you want to know more about why this is all you need to have a programming language. This programming language is Turing complete. So that means that TinyBasic can be used to solve the same kind of problems technically that Fortran is used for, or COBOL is used for, or other dialects of BASIC. To be clear, other dialects of BASIC, like Dartmouth BASIC going back to 1964, was already way more advanced than this. So TinyBasic is a slimmed down version of BASIC, but it needed to fit in that very tiny amount of memory. And so trade-offs had to be made. And these are the trade-offs that Allison chose to make, and they turned out to be a good starting point, a basis from which the language ended up getting expanded in multiple different versions. And it's very interesting, again, how little you need to have something that was actually useful for people, because people were really using this limited language to write their programs. Okay, now, I said at the beginning of the video that this is one of the first projects that was truly free software. What do I mean by that? Well, much later than this, in 1986, Richard Stallman, who kind of founded the formal free software movement, defined what it means for software to be free. So he defined what's called the free software definition. And he defined 4 freedoms, and because he's a computer guy, he started counting at 0, okay? So I'm going to go through these briefly and just explain why TinyBasic was truly the first free software program. So the first thing, the freedom to run the program as you wish for any purpose, freedom 0. Well, clearly that's what they were doing, because they wanted to kind of buck the system, not be beholden to corporations, and just be able to do whatever they want with their computers. That was the whole ethos of the Homebrew Computer Club and of a lot of the hobbyists that were getting involved in computers. It was like a fight the man kind of thing, bring the power to the people. Second, the freedom 1, freedom to study how the program works and change it so you can do your computing as you wish. Well, the prerequisite for this, Stallman says, of this freedom is access to the source code. So how can you study the software if you don't have the source code? They were explicitly distributing the source code through the magazine. This was pre-internet, so they couldn't distribute the source code just over the internet. And in fact, 1975 is even pre-floppy disks on personal computers. Floppy disks have been invented, but they weren't used on personal computers in 75. It took till 77, 78 to have floppy disks. So they were distributing the source code through magazines, but it's still distributing the source code. Next one, the freedom to redistribute copies so you can help others. Well, that was very clear from the first advertisement of TinyBasic. They were putting it out there purposely to help others and letting people freely redistribute it as much as they wanted to. And then the last one, the freedom to distribute copies of your modified versions to others. Again, Allison is explicitly encouraging people to be part of this participatory project, as he calls it. He wants folks to get involved, change what he did, improve it, and then distribute those improvements. So, by these four definitions, these four musts for something to be free software, absolutely TinyBasic is in this category. Now, it wasn't formalized, so I think what we have here is a difference between the spirit of the law and the letter of the law. Okay, TinyBasic definitely in the spirit of free software, but we don't have a legalistic framework for free software until Richard Stallman in the mid-1980s. But if we're thinking about the spirit of it, sure, we can definitely say TinyBasic is the first free software program. Bill Gates, now we go back to the history, okay? So we're back to the 70s. It's 1976, and Bill Gates is upset because folks he's not just upset about TinyBasic. I don't know if he's worrying about TinyBasic. He's upset because folks are copying Altair Basic. So Altair Basic, which they had spent a lot of time and actually money too, because they had spent money on renting those big iron computers later on. First, they were kind of using the computers at Harvard, but then once they moved to New Mexico, they're paying for computer time to develop Altair Basic. And he's actually dropped out of Harvard. They've started this business, this partnership, him and Paul Allen. They've actually hired some other employees. So this is a serious venture. This isn't just like a side project. And folks are copying it, especially in the Homebrew Computer Club. Folks were, according to quotes from the time, freely distributing it amongst each other. And there was not yet this idea necessarily in their minds that software is something you have to pay for, so folks weren't. And so Bill Gates calls their behavior, though, theft in this open letter that he writes to multiple computing clubs. And he says in the letter, and you can go read the letter yourself if you're interested, that you can't make quality software if folks aren't willing to pay the professionals who will make the software. Now, in the modern world, we have quality software that is built from the open source movement, from the free software movement, that isn't necessarily all having folks paid to do it. Now, of course, a lot of people are paid to work on open source software. So whether or not what Bill Gates is saying is completely true, I think reasonable people could disagree about. Certainly there is software that's made through the free software and open source movement where people are not being paid that is quality. So I don't want to say that there's not. But maybe you needed some folks to be paid to really kick off the profession of personal computer software developers. So I can definitely see his side of the argument here. And I bet if you were him and you had just developed something really special and people were just copying it like crazy, you would be upset too, is my guess. Unless you're the type of person who just likes to give everything away, which some people are like that. Some people are very much just about let's give to the community, and I admire those people. But I can see his point of view here. Okay, so he puts out this letter, and TinyBasic had already been kind of announced by Allison. It had already gone out there, and there had been these initial versions of it. But the letter actually angers that Bill Gates had written a lot of folks who are in this community. And so what happens is it actually encourages more versions of TinyBasic to come out. So folks actually took up the participatory call that Allison put out there, and they went and did port TinyBasic to other microprocessors. So not only was it on the 8080, it was ported to the 6502. It was ported to the Z80. It was ported to other early microprocessors. So folks were doing that, and folks were also improving on the original version of TinyBasic. And this was all being distributed through that magazine, Dr. Dobbs Journal. So Dr. Dobbs Journal would carry printouts and explanations from contributors who had taken the original TinyBasic and gone in other directions with it. So many versions of TinyBasic exist. There's not just one TinyBasic. And there's not just really one creator of TinyBasic. You could say that Allison is the original creator of TinyBasic. But when you say TinyBasic, it depends which version you're talking about. So there's one very influential version though. And that version is often called Palo Alto TinyBasic. And it was developed by a gentleman named Li-Chen Wang. And Li-Chen Wang developed a version that had some extensions to the original TinyBasic. So for example, it had support for arrays, and it had some additional commands. So it was an improved version. It might have had some performance improvements as well if you read about it. But beyond all of that, something even more notable about it is that he used a special term when he put it out there and distributed it, as all the other versions have been distributed in article form. He called it copyleft. And notice he didn't use the copyright symbol next to where he wrote copyleft. He used the @ symbol because in his new form of TinyBasic, actually the @ symbol is used for arrays, which is one of the features he added. I think that's why he used the @ symbol. But anyway, he wrote @copyleft, all wrongs reserved. Okay. I guess that's kind of a joke here, right? Because we're used to things saying copyright, all rights reserved, right? So all wrongs reserved is saying like we're reserving from doing anything wrong. So it's very much in the ethos of what Allison had originally put out there. And in this whole, and I'm using the word ethos way too much, right? But in this whole kind of world of let's put software out there for other people to build on and to have a community of software users who are all improving each other and helping each other instead of making it a commercial product. So I believe, and I haven't done the deep research, I've done limited research on this, that he may have really been the coiner of the term copyleft. So copyleft became a major term in the free software movement, and I'll talk about that in a moment. But we have to give credit to Li-Chen Wang, who actually came up with this term almost a decade before the free software movement got formalized by Stallman, and had the insight to really see that TinyBasic was really changing the world of how we think about intellectual property and how we think about sharing things that are developed by a community. So anyway, not only was he very innovative in coming up with the term copyleft, but his version of TinyBasic became a very popular version of TinyBasic. So I love it when figures in computing history have both kind of great technical chops, and they also have something that kind of crosses into, like, let's say, the world of the liberal arts or the world of thinking about our society. And I think Li-Chen Wang is definitely one of those figures. Okay, let's continue the history. So 1977 comes around, and some folks call the the major personal computers that come out that year, the Holy Trinity, when folks talk about the history of personal computers. They're the Apple II, the Commodore PET, and the TRS-80. These were three very influential machines from companies that weren't kind of fly-by-night, which many of these early personal computer companies were. They were companies that ended up having staying power, and they all would still be around 5 years later. So the Apple II, when it shipped, came with a version of BASIC called Integer BASIC that was developed by Steve Wozniak, who was the original creator, of course, of the Apple II itself. So he was both the hardware creator of the Apple II, and he also developed a lot of the software for the Apple II, including its version of BASIC called Integer BASIC. The Commodore PET, Commodore licensed originally a version of BASIC from Microsoft. And the TRS-80, this one's really interesting, actually used a version of TinyBasic. So the engineers who worked on the TRS-80 went and modified Li-Chen Wang's Palo Alto TinyBasic. According to what I read, they changed quite a bit of it, but nonetheless, it was based on his version of TinyBasic that became the first BASIC for the TRS-80. Now, Microsoft actually also ended up licensing Microsoft BASIC to Apple, and that then became known as AppleSoft BASIC ended up being the replacement for Integer BASIC that people used, and that happened pretty quickly after the Apple II came out. And actually, the TRS-80 ended up getting Microsoft BASIC as well. It was called like Level 2 BASIC, and the Li-Chen Wang derived BASIC was called Level 1 BASIC. And they ended up licensing more and more kind of Microsoft Basics for the TRS-80 line. So actually all three of the Holy Trinity ended up running Microsoft Basic. But I think, or a version of Microsoft Basic, or a Basic that was kind of derived from Microsoft Basic through some kind of licensing agreement. But I think it's kind of interesting that the TRS-80 was a commercial product where we saw this Basic that was actually a response to commercial products get reincorporated back into a commercial product. So I think that's kind of a nice side story here. But Microsoft Basic ended up being used eventually on all three of those lines of computers that started from the Holy Trinity. And in fact, Microsoft Basic became a completely dominant industry standard in the personal computer world. So, for example, the IBM PC, which defined the next standard of personal computers, came out in 1981, and it included built-in Microsoft Basic. It was called Cassette Basic on the first IBM PC, the PC 5150. The Commodore 64 continued to be built on a BASIC that was originally derived from Microsoft Basic, even though it got expanded and a lot of additions made to it. And these were the big computers of 1981, 1982. So as we enter the 1980s, Microsoft Basic is just completely dominant and it's becoming the industry standard. But with the IBM PC, we also see when the world is starting to move away from BASIC, because of course DOS, also made by Microsoft, is bundled with the IBM PC, and DOS in itself becomes the new user interface to personal computers. So if you turned on a personal computer in the late 1970s through to most of them still in the early 1980s, it would boot to a BASIC prompt. So you would right away be thrown into BASIC. BASIC was the user interface for using computers, just like it was for the Dartmouth time-sharing system for a lot of users all the way back in the 1960s. But we see the next transition happen with DOS and with other more sophisticated operating systems where folks now have a user interface that's not just a programming language that they open into. So we see that evolution, and we see something else happening in the 1980s, which is the free software movement becoming formalized. So Richard Stallman founds the Free Software Foundation in 1985. Around then, he's starting the GNU project, and he creates the first formal copyleft license in 1985 as well. So this is actually a decade after Palo Alto, Tiny Basic, and Li Chen Wang. From what I've read, Stallman was not directly inspired by Li Chen Wang's copyleft term that he used back in 1976. So from what I've read, this was a separate train of thought. Stallman actually heard it from someone else altogether. I don't know if there's a direct connection there from copyleft in 1976 in Palo Alto Basic and copyleft as the term that Stallman uses in 1985, if there's a chain of transmission there. But certainly, as we discussed earlier, you can't say that it wasn't a type of free software. So it's interesting because when you think about that, the movement really gets formalized in 85. They were as much as a decade ahead of their time, folks like Allison and Wang, who were starting this kind of Tiny Basic movement in the mid-70s. So I kind of made this timeline here where I put all the major events that we talked about together in one place. And you can see that kind of as Basic is rising, Tiny Basic is finding the perfect slot to be an opening salvo for the free software movement. But then by the time we get into the 1980s, we're seeing the erosion of BASIC as the main user interface, and we're seeing the market move away from hobbyists, scientists, and we're seeing it move to business users. And also folks who just want to play games or folks who just want to use a PC for entertainment. So we're actually seeing the user interface need to evolve as well and get more sophisticated, and that's where we're seeing operating systems take the place of the BASIC prompt. And we talked already about Microsoft DOS, but we're starting to also see machines that don't have BASIC built in at all. For example, when the Macintosh comes out in 1984, it doesn't have BASIC. And that was actually something people talked about. When the Macintosh comes out, if you look at some of the original magazine reports about it, people are like, well, it doesn't have BASIC. Apple is planning to actually license Microsoft BASIC and ship a version of BASIC, but BASIC is not built in to the Apple Macintosh. And so that was actually seen as a downside. Even though it had this much more sophisticated user interface than just a basic prompt, the basic standard was very much a standard, and Microsoft was at the heart of that standard. But TinyBasic was a very interesting kind of successful movement. We can't say that TinyBasic wasn't successful. It was used by many folks. It got shipped on commercial products. And going beyond this timeline, there's actually still a guy in Germany I found who's still shipping microcontrollers that use TinyBasic. So it's had its reach far beyond kind of this original timeline, both in terms of its influence of being an early proponent of free software, and also that folks still use it today, including as a great educational project. So if you want to learn how to write an interpreter, looking at that original grammar for TinyBasic and reading Allison's original specification for it gives you a great starting point for writing an extremely simple programming language. A programming language that has the bare minimum, again, it is Turing complete, but that you can use for real programs. And I think what's kind of cool is you can actually, if you write a TinyBasic interpreter, you can go and take actual programs from the 1970s and run them. The whole point of TinyBasic is it was supposed to be portable. So there weren't a lot of parts of programs that were written for TinyBasic in the 70s that were dependent on things that were specific to the hardware of the time. Because of course it would run across many different hardware platforms during the personal computer revolution. So you can take those programs and you can literally just run them in your interpreter you build today. And I do this when I teach. I used to teach a class on modern programming languages, and part of that was learning how programming languages work. And I had students do a project where they built a TinyBasic interpreter in a modern language. And I would give them a lot of starting code, but it was really eye-opening for a lot of them. How a programming language really works? No, you're not going to learn everything about how a modern programming language works, but you're going to learn enough that you get a sense. You get a pretty strong sense. You're going to learn about all the major components doing this project. How does a tokenizer work, which is the part of an interpreter that takes the original text file and figures out what are all those individual kind of words or characters in the original text file that actually matter, and how do we take them and put them into a stream that then we can feed to a parser. The parser actually finds the parts of meaning. It takes those tokens and puts them together into components that actually have real meaning. So we go from syntax to semantics. And then you have the runtime that actually executes the program. So you can build all three of those parts with TinyBasic and see how they work on such a simple language, but you start to see where the hooks are that you could put in to make it actually a much more sophisticated language. And that's actually the project in chapter 2 of my new book, Computer Science from Scratch. So it's all about building a version of TinyBasic that we in the book call NanoBASIC, because it even doesn't have those control mechanisms like clear and run, because it just runs text files as programs. We don't need those meta commands anyway. And we actually build the tokenizer, the parser, the whole thing from scratch. And you really learn a lot about how a programming language works by going through this exercise. And the book is all in Python. So if you check out chapter 2 and you already know a little bit of Python, you're going to get, let's say you're an intermediate programmer in Python, this book is a fantastic way to understand what's happening beneath the surface. So how does even like something like the Python interpreter, how does that work? You're not going to become like somebody who can dive into the Python interpreter source code and be able to add new modules to it necessarily, but you are going to get a sense by building this really simple programming language completely from scratch of what's going on. You're going to get the high level understanding. So if you're somebody who knows Python, but you don't know computer science, and you want to learn more about how programming languages work, please check out the book. Go to computersciencefromscratch.com. Anyway, hope you enjoyed this story of TinyBasic. I plan to do more videos like this, so if you're interested in them, please subscribe and like the video. Have an awesome day.